Here we want to find the intervals of increase and decrease of that function. So what we're going to do is take the derivative, and we're going to do that by using the quotient rule. And when we use the quotient rule and simplify it, we get x squared minus 10x minus 11 over x minus 5 quantity squared. We can factor that numerator, and we have this as an expression equaling the derivative of our original. Now, setting that equal to 0 means x is 11 or x is negative 1. Setting the denominator equal to 0 means x is 5. So, what we have then are 3 critical values of x. So we're going to test 4 different intervals. If we let x be less than negative 1, then we have a negative factor and a negative factor. And down below we'll have a negative factor squared, which is positive. So a negative times a negative divided by a positive will be positive, and we'll have an increasing function. Now, in between negative 1 and 5, we're going to have a negative factor times a positive factor in the numerator. Our denominator will be positive because we're squaring a negative. And ultimately we're going to have a negative derivative, and we'll be decreasing. Between x values of 5 and 11, we have a negative factor times a positive factor in the numerator. We have a positive factor being squared, so a positive number in the denominator. And multiplying all these factors and dividing as necessary, we have a negative derivative and a decreasing function. Finally, when x is greater than 11, all of our factors are positive. We have a positive derivative and an increasing function. So our intervals of increase are the first and the last, x less than negative 1 and x greater than 11. And our intervals of decrease are the ones in between, negative 1 less than x less than 5 and 5 less than x less than 11.